Hi all, today I'm going to do a quick video on how to calculate formal charge. Formal charge is important because I don't know if you have connected these dots maybe. Sorry, it's hard for me to say and write, but a lot of times in organic chemistry, we'll see charges on molecules, so for example, you might see an oxygen that's negatively charged, or you might see an oxygen that's positively charged, or you might see carbons that are positively charged. I'll zoom in a little bit here. You might see carbons that are positively charged, for example, something maybe like this. And a lot of times, especially for my OChem 2 students, that it's been a while since they've taken organic chemistry, they don't always know what that formal charge comes from or why there's a positive or a negative there. Or if I ask them, what's the formal charge on that? A lot of times they just say, I don't know. So the way that you calculate formal charge is first you have to find out how many valence electrons an atom typically has. So you can do this by looking at the periodic table. And the important thing to notice here are the numbers at the top of the column. So see how this has 1? So that indicates that hydrogen has 1 electron in its valence shell normally. Boron is in the 3 column, or 13. So you look at the second number there, there's the last digit. So it has 3 valence electrons. Carbon is in 14, so it has 4. Nitrogen 15, so it has 5. Oxygen 16, so it has 6. Halogen 17, so they have 7. So that's how you can tell. All of the things in this column have 3, this one have 4, this one have 5, this one 6, this 7, and then 18, so these have 8. So except helium has 2. So if it naturally comes with that many valence electrons, that's what you start with. So going back to our examples over here, if you have, for example, actually I'm going to draw in the lone pairs because there's also implied lone pairs a lot of times. So you can basically say the number of carbons from the periodic table, or the number of electrons from the periodic table. So there's 6 electrons from this periodic table. So oxygen normally comes with 6 electrons, and then you subtract the number of electrons and the number of bonds around it. Some people say minus dots, minus lines, but those dots and lines represent electrons. But if that's easy for you to remember, that's okay with me. So there's 1, 2, 3, 4, 5, 6 electrons here, and then 1 bond. So if we have 6 electrons minus 6, that's 0 minus 1, that gets us to -1. And that's why this has a negative formal charge. Now with this oxygen, there's only 1 lone pair. So we have 6 electrons from the periodic table. That never changes. Oxygen always has 6 because it's always in this 6 column. But in this structure, it has 2 electrons. So minus 2 electrons and 1, 2, 3 bonds. So 2 dots, 3 lines. So that equals 1. So that's a positive 1. So that's why that's positively charged. And then over here, carbon, this carbon has a positive charge. So you can sometimes use that to go backwards to see, is there any implied lone pairs? Are there any implied hydrogens or anything like that here? So in this case, this carbon has a, sorry, I didn't mean to zoom in just then. I was trying to focus. This carbon has a positive charge. So that must mean that if we look at the valence electrons, carbon has 4 valence electrons from the periodic table. So 4 minus what gets us to +1? 4 minus 3 leaves 1 behind. So there must be 3 things around this carbon, and we can see 1, 2, 3. So there's no implied hydrogens or no lone pairs that we can't see there. Similarly, if you just have an oxygen with a negative charge, you know that oxygen always starts with 6 electrons. So it must be -7 to equal -1. We only see 1 bond. So there must be 6 other things around to get this negative charge. So that's how we can fill in these lone pairs. Same here. This oxygen doesn't have any charge on it. So it must have 6 things around it. So 1, 2, 3, 4, 5, 6. So there's no charge on this. So that's just kind of a primer, an overview on how to calculate formal charge and what formal charge even is. Whoa, I don't even know what I just did. Oh, cool. You can rotate the camera. I didn't know that. Okay, so that's how you calculate formal charge and what formal charge even is and how it's used in organic chemistry. So if you're ever confused about what has a charge and why, or if it should have, how you know if it should have implied something like lone pairs or hydrogens or not, this is an overview of how you do that. Or if you're in Organic Chemistry 1, you probably have just been learning this, so it might be helpful to review. All right, well, I hope that's helpful to you. Good luck studying.